morning. Today we will discuss numerical problems on maximum power transfer theorem. In the last lecture, we have discussed the statement and proof of maximum power transfer theorem, and we have identified or we have derived the numerical expression for the maximum power which can be transferred to the load. We had concluded two things at the last lecture, that maximum power can be transferred in DC circuits if load resistance is equal to Thevenin's resistance, or we call it as internal resistance of the circuits. And maximum power transferred in this case is equal to PL max is equal to VTH square by 4 RTH. So to determine the maximum power, determine the maximum power that can be transferred to the load. This is what our target is. And how to determine the maximum power? It is equal to VTH square by 4 RTH, which means that you are supposed to determine the Thevenin's equivalent of the circuit, which will give you a VTH and also RTH. And then only you can determine the maximum power which can be transferred to the load. So in today's class, we will try to determine the maximum power which can be transferred to the load. So this is a question. Find the value of R. This is your R, such that maximum power is transferred from both of these current sources to this particular resistance. So you should find the value of R, and also you should find the power which can be transferred in case of maximum power transfer. So for this one, you should, for the first one, find the value of R. R is equal to the Thevenin's resistance. And if you want to determine the maximum power transfer, then you are supposed to determine both VTH and also RTH. So in either of the cases, you need to determine VTH and also RTH, which means you should determine the Thevenin's equivalent of the circuit. So we know that we do have 5 steps. We will follow step-by-step procedure and we will determine VTH and RTH, and then we will determine the maximum power which can be transferred. So this is your circuit, given circuit, right? So maximum power can be transferred only if the load resistance is equal to the circuit resistance. Besides, to determine the maximum power, what do we need? It is VTH square by 4 RTH, right? So we need Thevenin's voltage also. So we will compute the Thevenin's network using the 5 steps which we have learned. So what were the 5 steps which we have learned? The very first step was you remove the R. Number 2, determine VTH, which is nothing but your open circuit voltage. Number 3 is replace sources. Number 4, determine RTH. Number 5, VTH in series with RTH. You should draw the equivalent circuits and perform required calculations. So we will go step by step. First of all, I'll remove the resistance R. So removing the resistance R, the element across the X and Y terminals. This is yellow, so I'm removing it. So if I remove this one, the circuit will become like this. Okay. Now if you carefully see how many effective nodes are there. Even though I have mentioned their ABCD, ignore them. Ignore them. How many effective nodes are? If you carefully see, if I take this one as 0, this is 0, this is 0, and this is 0. And I don't know these things. If it was a voltage source, then I could have named it. But it is not a voltage source. So I'll take it as V1. So this is also V1, right? So this is also V1, or the same is x. So I will directly take it as Vx. Okay. So this is all Vx. And here, this I don't know. So this is y point. So I will directly take it as Vy. Okay. So this is Vy and this is the right. So how many effective nodes are there? There are 2 effective nodes. Okay. So there are 2 effective nodes. Now this is open circuited, right? It is not there. So this is Vx which I have taken. This is Vy. Okay. So 2 effective nodes x and y, and the voltages are named as Vx and Vy. So now at each of these effective nodes, you should determine you should apply the KCL. So now I am applying KCL. How many paths it has? This is one path which is already open circuited, path 2, and this is path 3, and this is path 4. Right. So the first path, the current is incoming, it is a direct current. So it is, I'll take it as -5. Second one, there is no direct current, so I should calculate it. Vx to the next point, it is 0, right? So Vx to 0 by 5. Vx minus 0 by 5. Third path, it is Vx to 0 by 2. And it is already open circuited, so I am not counting it. This is my equation. This entire equation is only in terms of Vx. So if I solve it, I can take LCM as 10. So this will become -25, this will become 2Vx, this will become 5Vx is equal to 0. So 7Vx is equal to 20. Sorry, this is 7Vx is equal to 50. So Vx is equal to 7.412 volts. Okay. Similarly, at node B, this is already open circuited. This is Vy. How many paths it has? 3 paths. This is already open circuited. No need to count. This is Vy minus 0 by 4. And here, if you carefully see, there is a direct current flowing in this one. And it is outgoing. So I will take it as +2. So Vy minus 0 by 4 +2. So if I solve it, the LCM is 4. I will get Vy is equal to -8. So here, Vx was 7 point something and here it is -8. So what is the difference between these two? This is your VTH, right? Open circuit voltage. So VTH is Vx minus Vy, 7.142 minus of -8, this will become +8. You'll get 15.142 volts. This is how VTH is calculated. Step number 3 is removing the sources. How many sources are there? 1 and 2. This is already open circuited. And these current sources are to be open circuited. Right. So here, I'll make it say this is current source. Current sources have been open circuited. Okay. So I have opened the current sources. So this is one, this is one. So now the effective network I'll show you now. This is the effective network, right? So if I redraw the network, this is RTH. This is 5 ohms, this is 2 ohms, and this is 4 ohm. This is already open circuited, no current is flowing, so I am just leaving it. So this is 5, 2 and 4. Now step number 4 is determining equivalent resistance. Now if you carefully see, these two are in parallel and the resultant one is in series with 4 ohms. So 5 ohms resistor is in parallel with 2 ohms resistor. The combination is in series with 4 ohms. What is the parallel relation with this parallel equivalent resistance? 5 and 2. 5 into 2 by 5 plus 2. Resultant one is in series with 4. If I solve it, I will get 5.42 units. Understood? So now what is my equivalent circuit now? The VTH is, I have got 15.142. RTH I have obtained 5.428. So what they have asked me, what is the value of R for which maximum power can be transferred? So maximum power can be transferred when RL is equal to RTH. When load resistance is equal to RTH, which is equal to 5.48 ohms. Similarly, what is the maximum power which can be transferred to the load? It is VTH square by 4 RTH. This is PL max. Okay. So VTH value I do have, RTH value I do have. So I have calculated it. I have got 10.56 watts. So this is the way how you need to calculate. Okay. So I hope that you are now able to determine the maximum power. Try to solve this problem. See, For the network shown in the figure, it is estimated that the unknown resistor R consumes maximum power at some condition. Write the condition at which load element receives maximum power. It is RL is equal to RI or RTH. And determine the value of unknown resistor. How to determine? You should determine the Thevenin's resistance. Where is R? See, this is R. And calculate the amount of power which is transferred at the instant with reference to 1. So you should calculate it and you should get me the answer. Okay. Done. So we'll solve more problems in the class. Come prepared for the class. Okay. Thank you.